ternary ionic compounds. So how do we know that the compounds are ternary? If they have 3 or more elements. And how do we know they are ionic, not molecular? Because they are made up of ions. You're going to see cation, which is positive, and you're going to see anions that are negatively charged. They are not very different from binary, but yes, they are still different because we are going to use polyatomic ions for ternary compounds. We don't have polyatomic ions when we are working with binary compounds. So we're going to work on naming and writing formulas. I'm going to show you some examples as usual, and then we're going to practice, and at the end you're going to work on your own. And guys, please don't miss my class, okay? Don't miss attending my class. I'm just making these videos so that you can use them if you are absent or just to review. Okay, here is the practice from binary compounds. Please pause the video and make sure that, remember, it works as a grid. You're making a compound using lithium and chlorine, lithium and phosphorus, lithium and oxygen, calcium and chlorine, calcium and phosphorus, calcium and oxygen. Okay, go ahead. Pause the video. If this is what you got, check your answers. Double check your answers. If these are your answers, that means you got how to name and write formulas for binary ionic compounds. Don't forget to use the valency chart. Okay, you're still using valency chart unless you remember everything in your head, that how the number of charges goes by the group number. So if you remember that, wonderful. If you don't, please use valency chart. It's on Google Classroom. Let's compare the binary and ionic compounds quickly. Binary and ternary ionic compounds. So binary, we use only 2 elements. They show only 2 elements and just monoatomic ions. Ternary have to have at least 1 polyatomic ion. Okay, monoatomic and polyatomic, or it could be polyatomic and polyatomic, only polyatomic ions. For binary, always the first element is always a metal. Here, sodium chloride and calcium oxide. Sodium is a metal, calcium is a metal. However, there are some exceptions. Usually the first element is metal in case of ternary compounds as well, but sometimes, look at this example of ammonium nitrate. You don't see any metal here. You have nitrogen, hydrogen, again nitrogen, again oxygen. However, it is still an ionic compound because it forms the ions the same way, and it is positive and negative ions. For binary compounds, the final formula always has the smallest possible ratio. For instance, here, manganese 4 oxide, you don't leave it here, you don't leave it as Mn2O4, you finally reduce to make it the smallest ratio, which is MnO2 here. Here some exceptions sometimes, and mainly the ions of mercury 1 and the oxalate ions. So what is the reason for that? Because these ions, they have particular structures, and that is reflected in their formulas, and we can change subscripts for them. Similarly, and the last one is ending. When you end the name of the binary compound, you end in IDE, meaning those anions are always ending in IDE. However, for ternary compounds, which include polyatomic ions, they end in ATE, they end in ITE, and they could end in IDE. IDE ending with IDE is not that many, but ATE and ITE are most of them. Okay, let's start with the example. So I'm going to start with naming first. Let's start with the naming first. So let's say you have K2SO3. Now K is plus, okay, and SO3, I want you to underline the polyatomic ions. Always underline polyatomic ions, and always start out keeping them in parentheses. Okay, and at the end, are we going to keep the parentheses or not? It depends on how many polyatomic ions we have. If we have only one polyatomic ion, we don't need to keep it in parentheses. If we have more than one, then we do need the parentheses. Like in this case, you see, there is no parentheses here. That's because you have one sulfide ion and you have two atoms of potassium, and you have this sulfide ion as one unit. All right, only one sulfide ion. Now here you have two atoms, so I'm going to leave it as 2. You don't see any subscript here, so that means 1. And this one is plus. What is this? This is the one you have to figure out. Okay, we also worked on finding the electroneutrality, how to make sure that the overall charge is 0. We had practiced when we were working on binary compounds. So you can go back and check there as well. So here 2 times 1. Okay, you have positive 2 here. So what should be this one? This has to be negative 2 in order to make it a neutral charge. Now you're going to use the valency chart. Please make sure you guys use the valency chart. It will be K plus and it is SO3 2 minus. Now using your valency chart, you're going to look for the names. You know, this one is monoatomic and this one is polyatomic. All right, you're going to use the valency chart. And this valency chart is on periodic table. Okay, on your Google Classroom. I already have it on Google Classroom. So for potassium, and then but you need to know for sulfide, that is all these ions here. If you look, everything that I have highlighted in yellow is the one with the transition metals, and one with those that forms more than one ion because of more than one charge. And everything that is underlined here, these are the polyatomic ions. So if you look at acetate, it's made up of carbon, hydrogen, oxygen. If you look at carbonate, it is made up of carbon and oxygen. All right, these are polyatomic ions because they are made up of more than 2 or more atoms but acting as one unit. Other one like bromide is just bromine, only one type of atom. Okay, so everything I have underlined, they are all polyatomic ions here. So you're looking for the name here. Which one we have here is, we have to look for SO3 2 minus. So look here at the very bottom on the right side here, sulfite SO3 and then 2 negative charge. Okay guys, so that is how you're going to use your valency chart. Must use valency chart for the naming and writing formulas. Okay, so this one is potassium sulfite. That's the answer. So what is the name of this compound here? This is the name, potassium sulfite. Make sure you use the valency chart, and please make sure that the charges on the compound are neutral. It's all together is neutral. They actually cancel the effect of each other, the protons and the electrons. Okay. Now, you could have also done this with backward crisscross, but that backward crisscross doesn't work all the time. So here is the polyatomic ion. You keep this in parentheses. You have one here, and when you do the backward crisscross, you take it up, you take it back up, it will be K plus SO4 2 minus, which is potassium sulfite. This is the example of sulfate. This is sulfate. Okay, so this is the way sometimes you can work with the backward crisscross. This backward crisscross doesn't work all the time. So do it the right way with the charges. Make sure that the compound is neutral, and once you know the charges, you can look at the periodic, the valency chart. Okay, guys. All right, so this was potassium sulfate, SO4. The one you did before was sulfide. And how do I know these names? I'm looking at the valency chart. That's what you're going to refer to. Let's take another example. Let's take something with variable charge. Okay, here. So this is the one with the variable charges, iron. It's a transition metal and it has 2 plus or 3 plus. We have to figure out which charge is being used here. So Fe, how many atoms of Fe do we have? We have 1. So we know that hydroxide is negative, and you have 3 atoms of hydroxide. You have 3 polyatomic ions. You have 3 hydroxide ions. Okay, so you're going to say you have 3 hydroxide ions here, and here you are given 1 iron. Now what should be the charge here? Let's say our charge is X. What should be the charge here to make sure that plus and minus charges cancel out each other? So this is 3 and this is negative 1, so this is negative 3. What should be this one? This is 1, so it has to be positive 3. Alright, to make the overall charge on the compound neutral, 0 charge. So what's our answer? Our answer is, what did we use? This is the charge we used here. So it is iron 3 hydroxide. How do I know that this is hydroxide, guys? I'm looking at the periodic table. Just make sure you always look at the periodic table for their names. Well, you will have to know by heart all these ions if you were taking AP class or IB class, but for general chemistry, just refer to the valency chart. Okay, now let's practice. Yeah, pause your video. Just make sure that you check that the overall charge on the compound is 0. You're using valency chart. Use Roman numerals. You're going to use Roman numerals if the cation, those elements, form more than 1 ion because of the ability to form multivalent charges. Okay, so if this is what you got, if these are your answers, that means you got it. All right, remember, where are we looking for these names? On the valency chart. And where is the valency chart? It's on Google Classroom. Okay, now writing formulas here. Writing formulas is not that difficult because all you have to do is look at the name and write the symbols for them mainly. So here, copper 2. You look at the valency chart and you're going to see, and it is already telling you that here the copper, the type of ion which is used here is copper 2 plus. You remember, this is a transition metal and the charge in the front is always for those metallic ions. It's never for non-metallic, it's always for metallic. So copper is how much? 2. So 2 plus. Now you look at the valency chart, and when you look at the valency chart, the formula for nitrite is NO2 minus. Okay, now remember that you never touch these subscript at the bottom, like nitrite is NO2. So you are making new substances using the original substance. What is your original substance? You have copper ions and you have nitrite ions. All right, you're not going to make any changes in the original substance, because if you change these little subscripts at the bottom, it changes the whole formula. It changes the whole, it makes a whole new substance. We are not trying to change our original substance. Yes, we are trying to make a new substance from the original substances. So here you crisscross. You remember, when the charges are unequal, 2 plus and 1 minus, you are going to crisscross. And when you crisscross, remember this 1 comes here. You don't need to write that 1. And this 2 comes here, outside parentheses. Very important, outside the parentheses. not inside. Otherwise, what will happen? If you put this 2 here, it will become 4 and this will remain 1. But no, that's not what we want. We want to keep this NO2 nitrite together. So this 2 comes outside. So when you're looking at the number of atoms, it will be 2 times 2, 4. 4 atoms of oxygen, and 2 times 1, 2 atoms of nitrogen. That's what is this nitrite ion here. So you have copper nitrite. Okay, so when you cross check for electroneutrality, so for 1 copper ion, which is 2 plus, you need 2 nitrate ion, because each one here, this is losing 2, so we need 2 of 2 nitrite ions, so that each nitrite ion can gain 1 of the electrons from Cu. Okay, all right. Okay, so what is the formula for copper 2 nitrite? This is the formula. This is the name and this is the formula. Copper. Let's work on another example. One more at least. So let's say ammonium nitrite, or maybe nitrate, because we did the nitrite. We did the nitrite? Yeah, we did the nitrite. So ammonium, you're going to look at the chart, valency chart, valency table, valency chart, ammonium and nitrate. And when you look there, ammonium is this one and nitrate is this one. Okay, these are the formulas for them. Now, you can tell right away, for 1 ammonium ion, you need only 1 nitrate ion to make this compound called ammonium nitrate. So we do not need to keep the parentheses. Regardless of whether I keep the parentheses or not, it's not going to make any difference, because anything multiplied by 1 is still going to give the same number. Okay, so here is the formula for ammonium nitrate. Okay. Now your turn. I want you guys to write the formula. Pause the video here. If these are the answers you got, you did the great job. Excellent, guys. Okay, all you did was you were looking at the valency chart for the name of these ions, for the symbols of these ions. And if the charges were different, you crisscross. Like in this case, you did crisscross. That's how you got 2 here and 1 here. Just the most important thing is, remember, when you're crisscrossing, those superscript, those numbers from superscript, when they become subscript, they have to be outside parentheses. Just remember that, because otherwise whole thing will be incorrect if they're not outside parentheses. And it's important because it is showing it is more than 1 ion. So here again, because opposite different charges, you crisscrossed, and here you cancel because they are the same charges. And they're equal charges. Opposite but equal. Okay, once again, where are you looking? You're looking at the valency chart for all of them. All right, so pause your video here. Make sure for the final answer, again, keep your polyatomic ions enclosed in parentheses if their number is greater than 1. So make a practice of starting out those polyatomic ions. When you start out with the names or writing formulas, just put them in parentheses. Later on, at the end, you decide whether they need parentheses or not. If these are the answers you got, you did a great job. Okay, good job, guys. Take care. All right, keep practicing.